Hey guys, I thought of sharing two specific as an overarching circuit problem, which you might find it helpful in practicing. So let's get on with the first one. So let's say I think you guys have seen this kind of circuit diagram in your practice problem also. So let's try to understand how we are approaching it. Okay. So the first question is asking you that what is the current through I1? Okay. So in order to answer that, so what we will do, we will first of all, again, using Kirchhoff's law. Okay, so using the Kirchhoff's law, let me just put this aside. So using the Kirchhoff's law, we will say that we pick out junctions. So how many junctions do you see? You basically see only two. That means whatever you decide here is going to be the same thing. And for convenience, I have picked out the arrows for the current, but even if you did not, feel free to do a random current direction and you will see that the answer actually comes out to be the same. You might have a relative minus sign, which is not a thing to be worried about. Okay, so let's say at the junction J1, the Kirchhoff's law starts from the junction rule at J1 is sum total of incoming currents is equal to sum total of outgoing. So there is no outgoing current, so hence zero. So this is basically, you may say, the start and end of all the problems here. Okay, because what we'll do now, our question is to understand I1. Now, here is I1, but we also don't know what is I2 and I3. So the thing that we have to going to do is pick out loop which basically relates this and this. So let's try to understand the first one, I1 and I2. So to have the relation between I1 and I2, we pick the loop A. So we start from the point A. We start from the point A as A, A, B, E, F, A. So in doing that, what do we do? So this is basically this. Okay. So doing that, we get VA minus I1 R1. So please get familiarized with the fiducial direction, the current direction. So I'm not doing that. It's there in my previous review of the mod 5. Please feel free to have that by your side. I'm just approaching the problem right now. Since in my circuit, this is like this, so it's along it, so negative. Here you will see the current is opposing it, hence this will be positive, I2, R2, and then you have jumping over V2, and then you're jumping over V1, hence VA, which basically gives us I1 R1 plus I2 R2 minus V2 minus V1 equal to 0. Now we want to find out the I2 in terms of I1, right? Because our target is I1, just remember. So in order to do that, I have I2 R2 equal to V2 minus V1 plus I1 R1. Good. Again, dividing both sides with the R2. Right? So this is the second equation we got. Now, we go for the third one. So let me just put this thing, this second page. Okay. Now we go for the other relation, which is 1 and 3, which is this. In order to do that, what we do, we take, again, we take A, B, C, D, E, F, and A. We basically take this. Okay. Now in doing that, again, why did we do it? Because this is the only loop which relates 1 and 3. Okay, that's what our objective is. Now again, going that, so minus I1 R1, just flowing through it. Again, I3 R3, negative V3, and then positive V1, and equal to VA. Good. Doing the same thing here, we have minus I1 R1 plus I3 R3 minus V3 plus V1 0. We want to find out the R3, so we get okay, which V comes out to be this. So this is the equation 3. See, so we got I2 in terms of I1, I3 in terms of I1. Now put everything back to equation 1. So putting back 2 and 3 in 1, get I1 plus I2 plus I3 equal to 0. Then what do we get? We get I1 plus 1 upon R2, V2 minus V1 plus I1 R1 plus 1 upon R3 . Okay, now since we are solving for I1, we have to isolate, keep everything which is in product with I1 in one side and all the others on the other side. So the first thing to do, as to understand that, we open up the brackets. This, and then you have we got this. So we know the ones with our I1, so we keep it in this side. All the others, we take it to the other side. And you know, when you take it to the other side, all the positive becomes negative and the negative becomes positive. Okay, it's a basic rule when you jump around the equality. So I1 plus so this flips the sign. That means the V1 is negative becomes positive, V2 is positive becomes negative. Hence, same happens here. We take it to the other side, which becomes V1 minus V3 R3. And here we take the I1s common. So basically when I take it out, in place of this, there will be 1. When I take this out, in place of this, it will be this. When I take this out, in place of this, it will be this. Hence, 1 plus R1 upon R2 plus R1 upon R3. And putting back all the V1s that we have. So V1 is this. So V0 minus half V naught, V2 is this, and my R's, R2 is twice of R. So V naught minus 1 by 3, V naught, this is Rifle's R. Again, so this is V naught 3 by 4 R. Oh, sorry, 1 by 4 plus this is 2 by 3, 2 by 9, V naught by R. And this again, let's put all the things R1s here. So this is R upon twice of R. This is R upon thrice of R. 1. This becomes what? 5, 6 plus 3 plus 2, 6. This is 9 plus 8, 36. So this is 17 by 36, V naught by R. So I naught becomes 17 upon 66, V naught upon R. Okay. Okay. So again, this entire thing is just math, which again, I would appreciate if you do it like this, stepwise. So you will reach the correct answer. The thing that you need to understand while doing this step and this step. So these things are the physics that needs to be checked and that will be tested, in a sense that I will be asking specifically what should be doing this. So, or I can ask you the loop which can relate I1 and I3 or something like that. Okay. Now, since we understand that, the next question is even more simpler. What is the potential drop across AB? So what is this asking you? It's asking you that you start from here and you end here. The potential drop across AB. You can take this also, that's fine. But since you know these two values readily, you can actually make your life simpler and take this route. So you're taking the route basically A, what is it? A F E B. A F E B. Now you might also have a doubt in your head that wait, I already have a point inside B and I didn't take that into account when I'm taking the loops here. So that's not the point here, because when you're taking the loop coming from one arbitrary point to another arbitrary point, we don't take all the arbitrary points in between. This point is there when we need to find out the potential difference between this and this. Okay, so whenever you are going from an arbitrary point to another, that arbitrary point is your focal point, or that point is of point of interest. Since in our earlier loops it was not point of interest, we can easily skip it and come back to the point that we took. Now, since that is the point of interest, we start off from this here, VA, and since our loop is like this, so it is basically negative V1 and then positive V2. Good. Negative V1, positive V2, VA, sorry, VB. Hence, the potential drop between A and B is V1 minus V2. V1 is V naught, and this is half V naught. Don't worry, here the sign came out to be positive, but it might happen that it can be an overall minus sign, so don't worry about that. So even in, let's say the exam, I'm just saying practicality that your answer came out to be overall minus sign to that of the options. Just be careful. It's nothing to be surprised of. You can easily tick that out. Okay, it's just an overall minus sign. So be wary that if your answer has an overall minus sign with respect to the answer that you see, feel confident that that is your answer. Okay, good. Now going on to the RC circuit, which is this. Okay, now in this RC circuit, you will see that I just pointed out two basic different circuits, and I'm trying to compare the relaxation time between them. Okay, so how do I go about? So this circuit obviously is very simple. So my relaxation time comes out to be R times C. Fine. Now my main target is to understand what is tau A. So in terms of doing that, I need to find out the equivalent resistance and equivalent capacitance. Now in order to do that, let's carve out this section and find the equivalent resistance. So let's do that. So I have okay, so this is R, this is R, this is R. So the next step of this is finding out the first equivalent resistance between the parallel circuit. This is basically can be done easily by parallel circuit, which is 1 upon R plus 1 upon R. Guys, please be very careful while you're doing the inverse and putting it back. Most of you guys are doing dimensionally wrong things. So once you do this, you invert it. Please make sure to invert it. Good. Now coming from here to here, this is now a series circuit, okay, which is basically R equivalent is R plus R1 Q. Okay, now let's come back to the capacitance. The capacitance also we will deal with the same way. Okay, again, first step, the first equivalent capacitance, which basically gives us, since it's in a parallel, so we know for the capacitance, the parallel gets added up, right? And now in series, the series gets invert addition. This is 3 by 2 C. Now invert it at the end. So we got this. So basically the product comes out to be REQ. CEQ is 3 by 2 R into 2 by 3 C RC. This is the tau A, so which basically tells me tau A is equal to tau B. Good. So that's all about the two kinds of overarching circuit diagrams that you will be tested on from the kind of chapter 2. So you should have a pretty good hold on how to deal with the circuits, and power will be questions regarding power will be very simplistic, will be mostly plug and check. So I think you guys are good. All right, guys. So I hope this kind of helps, and all the best. You guys got that. Okay.